So I spent, yeah, last 10 minutes and possibly 20 minutes yesterday in showing you how to build images with Singularity. Now I'm gonna tell you, no, don't build images with Singularity, please. It's it's better if you use Docker. And let's get this one right. So before you yell at me, let's just run this command on my Linux terminal. And then I'll expand on the point I've just made. So let's move into a directory, which is containing another definition file called a Dockerfile. And ask Docker this time to build a container image called, I don't know, locale. And then dot, which stays for the current directory. This will start a build process using Docker this time. You can see we need sudo again because similar to Singularity, any build process, actually a build process for most container engines these days requires sudo privileges. But why am I telling you, okay, ditch, forget about Singularity for building and go for Docker? Ultimately, it's up to you. Now, here I'm just giving you some elements to assess the two and pick the one you prefer. Remember that for building images with Singularity, you need any way to be outside the HPC share system because you can't run with sudo on an HPC system. So you would need a Singularity installation, again, on your laptop or on a cloud instance on your office workstation. But at that point, if you have sudo access to install Singularity, it comes quite straightforward to install Docker as well. So this doesn't complicate your setup that much. So Singularity has some advantages. The native image format is a single file. So it's basically trivial to share it with anyone because it's just a file. You can define in the definition file distinct usage modes, and you got an idea of that. So you can so the normal usage is with exec, but then you can define default commands with run, and most importantly, you can very unambiguously define the commands that you want to run to spawn long-running services with start script. And this is what this instance mention means. Whereas on these points, Docker is a bit less clear. You can often get confused. You might ask yourself, okay, what do I need to do with this image? How do I set it up? So that's a bit more blurred in Docker. Singularity has some quite powerful ways to set up the shell environment in the definition file. I didn't cover all of that in the previous presentation, but it has some interesting syntax. And also Singularity has a lot of stress on the security and signing of container images. And this partly goes back to the discussion we had yesterday. So you might want to find ways to ensure that the image you ship is actually the one that was created. So you want to ensure that you know what you installed in the image, and the image you're running is actually the one containing those files and not an image that has been corrupted by hackers or whatever. So Singularity has got some good facilities there. So what's on the Docker side? So first, the second point, Docker has a multiple file format. So you don't have a single file, you have a layered image, which is broken down in chunks in your file system. So it's a bit more complicated to move around. But this caching of, layering of the image allows caching during the build process. So it can be quite useful for when you're testing the build of your application in the container. But honestly, you could live without that. The big point is actually the first one, compatibility. So a Singularity image can only be run by Singularity, whereas a Docker image can be run by any container engine. And this is quite important because it's not up entirely to you to decide what is the engine in a shared system, right? You will never get Docker in an HPC side, but you might get other container runtimes that only read Docker images. Or you might ship and share your image with collaborators that are unable to use Singularity. So Docker images ensure this type of compatibility with any container engine. And the other point here is also that if you want to share images with Docker, you have this place called Docker Hub, or you have T.io for bioinformatics, and both these registries assume and use Docker image format. So when you build images with Docker, you are becoming part of this huge community of container image creators and users, and that alone is a huge point for building images with Docker. Because the bottom line is, depending on which one you use for building, you need to learn a different syntax for the definition file or Docker file. So what happened to me, for instance, I started with Docker. I learned the syntax very well. Then Singularity came out. I kind of learned the syntax that I just showed you for definition files, but then it was like, okay, I don't want to keep on using two languages, and they just remained with Docker because it was so much popular compared to Singularity. But hold with me, so it's not as bad as it sounds, because I believe I presented you the build process with Singularity and the structure of definition file in a quite general way. So it will be quite straightforward for you right now to get what are the differences that you need to pick to use Docker for building. So we mentioned with Singularity definition files that you have 4 key sections to keep in mind: starting image, Linux commands, shell variables, and copying files if you wish to. And here I'm providing you the corresponding syntax in Docker. So you specify starting image with the from directive, you execute Linux commands with run, define shell variables with env, and copy files with add or copy. And that's basically what all you need to know for writing a Docker file, so a definition file for Docker. And then I'm going to show you the example in a couple of minutes. I'm just letting the build to finish in my terminal. Okay. And this is one point. One other important point that you're going to see soon in the Docker file. So you saw in the Singularity definition file with sections, post, environment, and so on. The syntax I just showed you for Docker, such as run, are more like directives to be prepended to each command. So you won't have a single run section, but rather each Linux command to be run will start with run. So you basically will see in longer Docker files multiple appearances of run, of env, and so on, because these are more like keywords, they're not section headers. And then just relating back to what I mentioned, the fact that Docker images are structured in layers. The thing is, each instruction in the Docker file maps to one layer. And so that's how you know how many layers you have in a Docker file, for instance. Now, hopefully, okay, I've talked long enough, so the build is finished. So you see the last line says successfully built and the string, and successfully tagged lolcow today. So let me show you the Docker file, so where hopefully you can find the hints of what I just showed in the slide. So first line, you see the from directive to define the Ubuntu 18.04 container that we're using as the base image. Then we're using the label directive to define an author and a version label, similar to what we did in the Singularity image. And then here we're using the run directive to execute the Linux commands. Here I could have used two, one for the first apt-get and one for the second one. For whatever reason, I decided to just concatenate them in a single go, but the key point is use run to execute Linux commands. And then here env is used to define an environment variable path in this case. And okay, very last thing, if you really want to have a default command, so the matching of run script in Singularity is cmd in Docker. Okay, so that's the Docker file, so the definition file for Docker images. We've built the image. Now, in this context, I want to keep the usage of Docker really just confined to the build process. So the next thing I'm going to show you is how to convert the Docker image into Singularity 1, because soon after we are done with the building with Docker, we have achieved this point of having a universally compatible Docker image. Now we want to know how to share it and how to use it with Singularity. So let me go back to the slides. So we saw how to build with Docker, with sudo docker build, and the image name and tag with -t, and just specifying where the Dockerfile sits, current directory. And then, okay, the next command is the one that allows you to basically convert the Docker image into a Singularity 1. So as far as you have both Singularity and Docker installed in your build machine, you can achieve that. So Singularity pool, yes, and then you're gonna name your Singularity image. And then we are gonna tell Singularity where to look for the image to pull, and it won't be Docker as we did yesterday, because that would point to an online registry. It will be Docker daemon, which instead points to the local Docker installation. And I believe I've called the image lockout there. Yes, this is just a little bug in the current Singularity installation. With Docker daemon, you have to skip the 2 slashes. All right, so and this will basically just convert the Docker image into the Singularity 1. And soon, this one was small, so it will just take a couple of minutes. And when we're done, we have our Singularity image that you can use. And that's it. So the only difference is that we built the image with Docker. So you know the syntax now, Docker build. You get a very introductive view on the key Docker directives to put in a Dockerfile. And that's it. We're back to Singularity. The very last thing you might need to do with Docker is that if you want to make the image available in a public registry, you will use Docker push to upload your image to, say, Docker Hub or key.io, wherever. You will need a free account to do that, and then you will be good to go. And that's it for building images with Docker.
Okay, we have a very interesting question. Is there a technical reason of why sudo or root privileges are needed for building with Singularity and with Docker? A technical reason.
Yeah, so I know, so basically this comes down to how these container runtimes are implemented and how they work. So for Singularity, it's quite neat. Basically, you need sudo to run Singularity build, because the privileges that you will have in the build context inside Singularity will be the same that you have in the machine you're running the commands from. So if you need, so often, let me show you, let me just show you the definition file. So any package manager from Linux flavors, such as apt-get from Ubuntu, this will need sudo. It won't work without. So you need sudo to execute this during the build, and the only way to achieve this with Singularity is to run Singularity build with sudo. Because basically with Singularity, the user and privileges you get inside the container and inside the build context are the same that you get outside. So if you need sudo inside, you must run Singularity build with sudo from the outside. And more at low level, it means there is a bunch of operations that Singularity needs to perform that require elevated privileges. And as regards Docker, I don't have a similar detailed breakdown, but in the end, it boils down to similar concepts. So there are portions that, actually there are commands that need to be executed for the build and need sudo, and so you need sudo for Docker. But Docker actually is a bit even it needs even more from you, because any Docker command, not only Docker build, needs sudo, and that's because of the way the developers implemented things in Docker. So there is even just to spawn, to launch a container, Docker will need sudo, and that's because it needs to interact with some part of your machine that requires sudo privileges. And if you remember, so from the introduction yesterday, that's why people came out with a solution such as Singularity, so that at least for running containers, you don't need the user to have elevated privileges. But ultimately, there is a number of aspects in using containers that actually require this type of privileges.
Okay, thanks. There's some tips being shared on how to keep Singularity images small, or Docker images for that matter. Do you have any tips yourself?
Yes. So yes. So we some of these might be documented a bit more in the tutorial. I will just mention one that is quite key, that is not implemented here just because this is a toy Dockerfile, but the key one is, for instance, to clean up your build process. So say if you use apt-get, you should have an apt clean at the end of this. And then if you look for best practices Docker files, and then we'll see if there is one in the tutorial materials. If you have a look at those, you'll see that for apt, you can also manually remove files in given temporary locations, and that will save some space. With conda, you want to do conda clean. If you are compiling the tool yourself, you want to then say with config make install. After you have installed the executables in a given location, you want to wipe the source code, so to save space. But then this is not enough. So say you had apt clean, you need to do that within the same run directive. So within the same layer in the image. And that's why, that's because when Docker builds the image, it does it in stages, in layers, and Docker keeps track and snapshot of each layer in the final image. So if you say, get some temporary files with apt-get to install these packages in a run command, and then you use another run command to delete those temporary files, those will still be in the final image, because Docker needs to cache a snapshot all of the single layers inside the image. That's by design. That's what allows the caching of the build process. So if you want to really save space, you need to add apt clean at the end, and this needs to be all within the same run, all within the same layer. This way, Docker will save in the image just the end result, so the installed packages without the temporary files that you actually clean. And that's it. So this is possibly one of the most common and easy tip to implement in Docker files to reduce the image size. There are more elaborated one, which would take possibly a dedicated webinar. So I'm not entering into detail today.